Okay, we're going to be doing right triangle trigonometry, which is something you have done at least 5 times in various classes, so this should be a quick lesson. If we're looking at theta to be our lower right-hand angle, then the opposite, hypotenuse, and adjacent are what we want to look at for right triangle trig. So this one, the one angle, the side across from the right angle is always the hypotenuse. The angle directly, the side directly across from our angle theta is our opposite. And the side right next to our angle theta is the adjacent. Obviously those change depending on which angle theta we choose, but just based off of that angle theta, those are our 3. So if I'm looking at the trig ratios, knowing SOHCAHTOA, of course, using our shortcuts down here, so I don't have to write out the whole words. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The other 3 are all reciprocals of that, so hypotenuse over opposite for cosecant. Secant is hypotenuse over adjacent. And adjacent over opposite for cotangent. How do we find the length of the third side of a right triangle? If we have 2, we're going to use Pythagorean theorem, which you have also used several times at this point. Pythagorean theorem is a squared plus b squared equals c squared. If this was a small sketch of a right triangle, C is always the side opposite the right angle. A and B doesn't really matter the order that they're in since you're adding on that side. Okay, we're going to find the 6 exact values of theta. Theta is going to be down here. So first we need to figure out what that side of the hypotenuse is using Pythagorean theorem. So we need to find the side C. So it doesn't matter the order that the other 2 sides are in, just a squared plus b squared. Solving for C. So C is 5, so this third side is 5. Now all 6 trig functions, sine is opposite over hypotenuse, which is 4 over 5. Cosine is adjacent over hypotenuse, which is 3 over 5. And tangent is opposite over adjacent, which is 3 over 4. Or 4 over 3, sorry. And cosecant, we flip it over. The second 3 are always very easy once you find the first 3. Okay. Use the triangle to find the 6 trig functions. So again, theta would be down here. Have to find that third side. If you recognize this already, this is a Pythagorean triple. Just like the last one was a Pythagorean triple, our third side is 12. If you're not recognizing that, you would set up the 5 squared plus b squared equals 13 squared and solve it for b, and you would get 12. So now we find our 6 functions. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. The other 3 are just flipped over. Okay. The trig functions of a 45-degree angle. This third side is the square root of 2, which you could figure out with Pythagorean theorem. These you don't have to memorize, but they're just helpful. Sine of any angle theta is the square root of 2 over 2. So theta could be here or here in this case. Since it's a isosceles, it doesn't matter which angle you're picking. You're obviously not picking the right angle, but the other 2 are the same. Cosine is also square root of 2 over 2. and tangent would be 1. Just the big three are important here if we're just summarizing this quickly. And again, we'll do 30 and 60. Let's start with 60. Sine of 60 would be the square root of 3 over 2. Cosine of 60 would be 1/2. And tangent of 60 is square root of 3. We'll do the same thing only with the 30-degree angle now. Sine of 30 is 1/2. Cosine of 30 is the square root of 3 over 2. And tangent of 30 is 1 over the square root of 3, which we can't leave that way. It turns into the square root of 3 over 3. So we have already actually been using these reciprocal identities the whole time, recognizing that cosecant is a reciprocal of sine, so sine would be 1 over cosecant, and cosecant would be 1 over sine. And all the other ones are the same way. Cosine is 1 over secant, secant is 1 over cosine, tangent is 1 over cotangent, and cotangent's 1 over tangent. Also, a couple of quotient identities. We've kind of been using them when we used the unit circle in the last section. Tangent was y over x. Y corresponds to sine. X corresponds to cosine. So it follows that tangent is sine over cosine. And cotangent is a reciprocal, which would be cosine over sine. And there are 3 big Pythagorean identities which we will be using now and forever, pretty much. First one is sine squared plus cosine squared equals 1. This is a big one. If you want to star that so we know it's important. 1 plus tangent squared theta equals secant squared theta. It's another one we use. And the last one is less commonly used, but we should still know how to use it. 1 plus cotangent squared equals cosecant squared. So if theta is an acute angle where sine of theta is 0.6, find the values of cosine theta and tangent theta using trig identities. So the first thing I'm going to use, if I'm trying to find a cosine and I have sine, is I'm going to use the one we just start up there, because that's saying that I can, if I have one or the other, I can solve for the other one. So sine is 0.6, so I would do 0.6 squared plus cosine squared equals 1, just using that identity up above that I starred. So that's 0.36 plus cosine squared equals 1. Cosine squared equals 0.64 when I subtract that over and take the square root and I get 0.8. I'm not going to have plus or minus 0.8, we'll just stick with the positive because it's an acute angle. If the sine is positive, the cosine is positive if it's acute. And B, we're trying to find tangent. So I would just use my quotient identity up here, that tangent is sine over cosine. Now that we have both, sine was 0.6, cosine was 0.8, so tangent is 0.75. Okay, use trig identities to transform one side to the other, so that means that I cannot touch both sides. I'm only working on one side at a time. So I'm going to start at the harder side, the cosine secant side, and I'm going to use the fact that secant is the reciprocal of cosine. So secant is 1 over cosine. And those cancel, so I sure did get to 1. B, there's not much that we can do here. I see 2 binomials. My instinct is to FOIL. So if I can't see what to do immediately, that's what I'm going to do. I'm going to FOIL or do anything that I would know. So FOILing, I will get secant squared minus secant tangent plus secant tangent minus tangent squared equals 1. My two middle terms cancel out, so I just have secant squared minus tangent squared, and I'm trying to get this to 1. Well, if I look at my identity on the previous page, my Pythagorean identity, it was 1 plus tangent squared equals secant squared. What I have on my left side here is actually just rearranged. I just subtracted the tangent and I got 1. So I'm actually done already. I just need to recognize that I'm done using this as my identity. And the last thing we're going to do is something you've done a lot, is using trig to solve right triangles. So that's our SOHCAHTOA that we're going to use. Angle of elevation is always from the horizontal up, and the angle of depression is always from the horizontal down. So just be careful knowing that the depression is from the horizontal down, not necessarily just the top angle of the triangle. So we have a surveyor standing 50 feet from the base of a large tree. 50 feet here. He angles the measure of elevation to the top of the tree to be 71.5 degrees. For the record now, none of my pictures are going to be drawn to scale. How tall is the tree? So I want to know what the tree is. So using my angle theta here, this is going to be my theta, the one they gave us. I have I'm trying to find the opposite side of that angle, and I have the adjacent, so I'm going to use tangent. Tangent of my angle is x over 50, and I would multiply both sides by 50 to get x alone, and x is 149.4 feet, making sure that you are in degree mode in your calculators. Two more quick examples of solving for triangles. We are 200 yards from a river. So here's my river. I'm 200 yards from the river. Rather than walking directly to it, there's a 400 yards, along a straight path to the river's edge. Find the acute angle between the path and the edge, which would be right there. So there's my right angle, which means I have the hypotenuse, which is 400, and I have opposite to my angle, which is the 200. So I would use sine of theta equals 200 over 400. When I'm trying to solve for an angle, so I have sine of theta, and I'm trying to find theta, I have to take the inverse, sine inverse of my 200 over 400 to get theta. And that tells us that theta should be 30 degrees. That's the only way to find an angle when you're taking the trig function of it, is to take the inverse trig function of that angle. And the last thing we're going to do is find this length of the skateboard ramp. Again, we are, C would be the hypotenuse, so we're going to use sine again. Sine of 18.4 was 4 over C. This one's a little different because I'd have to multiply both sides by C to get it off the bottom, and then divide by sine of 18.4. So C is 12.7 feet. And below is our assignment, and that was section 3.